Welcome to clickmyproject.com. Now I am going to discuss about bias discriminant Euclidean embedding for content-based image retrieval. Here we address the novel technique in content-based image retrieval. We use the method called bias discriminant Euclidean embedding. CBR is a technique to retrieve images from an image database such that retrieved images are relevant to a query image provided by user. The low-level features are extracted from an images from the basis of color, texture, shape. Relevant feedback method is used to retrieve the images. Here we have the positive samples and negative samples. The related image of query is called the positive sample and unrelated image is the negative sample. When a query image is given, the low-level visual features are extracted. Then all the images in the database are sorted based on the Euclidean method. If the user is satisfied with the result, the retrieval process is ended, so it will prevent from the false retrieval. Now let's see the flow of our project. First we have to provide a query image. For this query image, here we are extracting a 3 features. First one is color feature, second one is the shape feature, third one is texture feature. For color feature, here we are extracting a hue, saturation, intensity values. Then we are extracting the color coherence intensity values. Color coherence vector is denoted the color values of the querying image. In shape feature, here we are using the gather feature. Gather feature is used for extracting the edge information about the query image. In texture feature, here we are using the GLCM algorithm. GLCM algorithm is the statistical information about the query image, such as energy, entropy, correlation. These three feature values will go to the bias discriminant Euclidean embedding. Here we are computing the distance values of the query image versus database images. These distance values will go to the relevance feedback method. In relevance feedback method, the database images are sorted based on the minimum distance of the query images. These sorted images are retrieved in the image retrieval process. Now let's see the execution part. Here I am having the bias main.m file. Select this file, right click and run the file. The guide window will be open. This is the guide design of our project. First we have to select the query image. In query image folder I am having the 4 images. First is the building image, second is the natural image, third is the human image, fourth is the cartoon image. Now I am selecting the building image. For this query image I am extracting the color feature. In color feature, hue, saturation, intensity values with color coherence vectors will be extracted. The extracted feature values will be displayed in the first table. In shape feature I am using the gather algorithm. It will provide the edge information about the query image. The corresponding feature values will be displayed in the second table. For texture feature I am using the GLCM algorithm. It will provide the statistical information about the query image. The corresponding values will be displayed in the third table. These three feature values will go to the BDE retrieval. In BDE, Euclidean distance will be computed between the query image and database image. The distance values will be sorted and the corresponding image will be retrieved from the database. Now let's see the result of BDE retrieval. These are all the irrelevant image to our BDE retrieval. These are all the relevant image to the BDE retrieval. These are the distance values between the query image with the database images. The values are plotted as a bar chart. In semi-BDE is the existing method. This method has the false result. To reduce this, the user feedback will be there. The user have to select the relevant and irrelevant images for the result. Now we have to select the relevant images. Now we have to select the irrelevant images. These are all the irrelevant images in the semi-BDE retrieval. This is the relevant images in the semi-BDE retrieval. This is the comparison graph between the BDE and semi BDE. Our proposed BDE is better than the semi BDE. It will provide the better result than semi BDE. Thank you.